Right, so in this video, we're going to maximize a quadratic function, okay? So the problem, most cars get their best gas mileage when traveling at a relatively modest speed, okay? The gas mileage variable m for a certain new car is modeled by the following function. So m of s equals negative 1/28 s squared plus 3s minus 31, okay? This model only works over the domain of a speed from 15 miles per hour to 70 miles per hour, okay? Again, S is the speed in miles per hour, and M is the mileage, okay? Gas mileage in miles per gallon. All right, what we want to do is figure out what the car's best gas mileage is and what speed makes that happen, okay? So, S is the independent variable, okay? So we'll think of S as the X variable here, and M is the dependent variable. So if you're thinking of Y and X, S would be the X coordinate, M would be the Y coordinate. S is independent, M is dependent, all right? So in order to find the maximum or minimum, okay, you've worked with quadratics quite a bit now. In order to find the max or the minimum, remember you have to find the vertex, okay? So we're gonna need the X coordinate or the S coordinate in this case, and the M coordinate to find the maximum gas mileage and the speed that achieves that, okay? So this equation is in standard form, so we're going to use negative b over 2a to find our vertex S coordinate, okay? Negative b over 2a. So we're going to plug our values in. A was negative 1/28, b was 3, and c was negative 31. Okay, so let's plug in the values. We've got negative 3 over 2a, okay? In the denominator, that simplifies to negative 1 over 14. And then I'm going to multiply by the reciprocal, which gives me negative 3 times negative 14, which gives me a speed of positive 42 miles per hour, okay? If you got a negative value here, you know you made a mistake. The speed has to be positive here for this case, okay? So this is the X coordinate or the S coordinate in this case. This speed is going to maximize our gas mileage. Now we just need to figure out what that mileage is, okay? So we're going to plug this value back into our original equation. So we're going to find the vertex M coordinate now. And I'm going to plug in 42 for S in both these spots, okay? So M of 42, so the mileage at 42 miles per hour is going to equal negative 1/28 times 42 squared plus 3 times 42 minus 31, okay? Order of operations, so I need to square the 42 first, and that's going to give me 1764. I'm going to multiply 3 times 42 here. That's going to give me 126. And I'm just going to bring down the minus 31, okay? Order of operations again, I'm going to multiply negative 1/28 times 1764. And that gives me negative 63. I'm going to go ahead and combine these two. That's going to give me a positive 95. All right, so now I've got negative 63 plus 95, and that gives me 32 miles per gallon. So at 42 miles per hour, I achieve a maximum mileage here of 32 miles per gallon, okay? So that's how you determine what the maximum value is or how you maximize a function, okay? Understand what functions can be maximized and which can be minimized. Notice my a value here is negative. That indicates I've got a parabola that opens downward, which creates a maximum, okay? I couldn't maximize a function that had a positive leading coefficient. So that's one of the things you want to look for when you're either maximizing quadratic functions or minimizing quadratic functions.